Welcome to our Advanced Robotics Center. We are now in one of the labs in our Advanced Robotics Center in National University of Singapore, where in this workshop, you will learn some of the basics of using computers to make machines more intelligent, right? To be more useful to serve in our daily lives. Yeah. First, what are the basics? The machine needs to be able to understand input and output, understand the environment. So it needs sensors to read the environment, to understand the state of the environment, right? After it has understood the environment by reading the sensors, it needs to do some decision making, right? Think what to do, right? And using the brain or artificial intelligence perhaps. And after that, after he has thought what to do, then it has to do the actions to control the environment, to help us living in the environment, right? To do actuation. So first sensing, understanding, then actuation, doing some things to help people, right? When you're doing this sensing, understanding, and action, you want the robot to be able to learn. So next time, the robot can be more intelligent, right? So, and how to improve over experience by learning from its sensing and action. Learning to sense better, learning to understand better, and learning to do better, right? Or learning everything together, right? It's typical to how humans learn, right? So in this workshop, you will learn all these aspects from basic sensing, basic understanding, basic action, and all using a computer. And the computer doesn't have to be a big computer, it can be a small computer as long as it has some decision-making capability. So here you can see some of the applications. For example, here is an autonomous vehicle, right? Where we have the computer here. It's using NVIDIA Jetson board that is programmed or that is hardware designed to do fast parallel processing because that imitates the very basic approximation of the human brain, where you have many brain cells operating in parallel, learning through data. And we have some sensors like a camera. In the workshop, you'll see how a camera is going to be used to as a basic sensor. And we have, in this vehicle, we have other sensors too. For example, the LiDAR here. And this is understanding the environment. The LiDAR just senses the distance of objects around the vehicle. And after you understand it, after the computer understands it, it needs to control the motor to make the vehicle move to a destination. And for example, there's a small motor here that turns the steering wheel, turns this left and right. You can see the motor turning as it's turning left and right. And the same computer controls the motor here to make it move forward and backward. So this is one example of this. This is another example of a robot. The same thing, you see the motors here, you see the sensors here, another kind of sensor here for detecting range. And the computer is under here, you don't see it, it's somewhere hidden there, right? Because mobility, getting a robot to move is very important. For example, you can sit on it, you can move, or you can put your things on it and it can follow you. For example, in the airport. For example, you're in the airport, the robot, your luggage is on the robot and it follows you around, so you don't need to carry the luggage. But a very interesting sensor, a very interesting robot configuration is something like this. A robot that can have omnidirectional motion like this, right? And this is one example of that robot that can do omnidirectional. It can do this, it can do this, right? Through mechanical design. Imagine if our cars can also move like this, then you don't have a problem with parallel parking. Right? And this is inspired from this, exactly the same. So this wheel is like this, similar, and you have two wheels here, these two. So instead of you pushing it, we make the motor turn, and when the motor turns, it does this. You can do things like this. So here in this center, we design mobility. We design robots that can do this. We also have different designs here, as you can see, different kinds of mobility devices for doing more. We can also have this this is too big. If you want something smaller, you can have something like this, like a toy car. The computer is there, the camera is here, and it's all moving by itself. and can do around this lab, can do things like this. But robots is not only about vehicles, it's also about here. If you go behind here, it can also be an arm, something like this, a robot arm that can move and help you. And this arm is very soft, it's safe, it's called a human collaborative robot. If this robot can help you when you're doing some things, this robot, for example, can hold a water bottle while you're doing some assembly and can do things in a human-robot collaborative way, right? And sometimes you will need the robot to also do some things, but you don't want to be close to it. You want to control it from outside. You can also use this haptic device. It's like a joystick. You can do this. You can move it around, and the robot is moving. And once the robot touches something or carries something heavy, you can feel it. That's why it's called haptics, means sense of feeling. You can feel what the robot is feeling. It improves the way you interact with the robot. So in this lab, we do all these things, and the basics is how to design a robot, right, like this, or a moving robot to do some intelligent action. But before it can do some intelligent action, it needs to sense the environment using sensors like a camera. And once it senses the environment, then it can control it while working with humans, right? So I hope you will enjoy the time here, the workshop, to test you, to teach you, or to show you the basic capabilities of sensing, understanding the environment, doing actions, and learning. Thank you very much.